Hey everyone, so today I want to go over chapter 10 and we're going to hit on length, area, and volume. So, hi, my name is Heather and I hope that I'm able to lend you a little bit more information on figuring these things out in mathematics. So first we have some pictures right here. And it's just really telling how many mouthfuls equal like 1 gill, 1 cup, 1 pint. We want to know in this next slide when you look at it, if you have a pail, how many mouthfuls are going to fill up this pail, or is it going to overflow? Can you put more in it? I represented using clouds, and each cloud represents 8 mouthfuls or 1 gill. So there are 32 gills in this container, but there's room for only one more mouthful. So it's not overflowing, it's not completely filled to the rim. So you can add one more mouthful and it'll be completely full. Alrighty. Next, we're going to look at some triangles. In this first one, we have one huge triangle divided into 2 right triangles. And you have 48 meters, 69 meters, and 82.3 meters as the sides of the bigger triangle. Now, the height of the triangle is going to be 41.0 meters. We want to find the area and the perimeter of this triangle. So, the area is going to equal 1/2 the base times the height. So we know that the base is going to be 82.3 meters and the height is going to be 41.0 meters. So you're going to again have 1/2 of 82.3 meters times 41.0 meters. So the area of this triangle is going to be 1,687.15 meters squared. Don't forget you have to square it since you're doing the base times the height. And now we want to look for the perimeter. So the perimeter of the triangle is just all its sides added together. So you're going to have 48.0 meters plus 69.0 meters plus 82.3 meters. Now, since you're just adding them, you're not going to make this a metered square with your total. So the total is going to be 199.3 meters. Here's just another example. It's another right triangle with the sides 96.2 inches, 88.8 inches, and 37.0 inches. Again, you're looking for the area and the perimeter. You'll use the same equations. So right here you have the base of 88.8 inches and the height of 37.0 inches. So you have an area of 1,642.8 inches squared. Again, remember you have to square it, and a perimeter of 222 inches. This following slide is the same thing. It's just another type of triangle, and you kind of like do the dotted lines to make it into a right triangle so you can work on it a little easier than an isosceles triangle. Same equation, 1/2 of the base times height. And then the perimeter again is just all your sides, 6.2, 8.5, and then 3.1, since that's your other side of the isosceles triangle. All right, now we have a circle, we have a square, and we have another circle. So you have a circle inscribed into, or a square inscribed into the circle, and then you have another circle as the circumference. Now what we're wanting to know is the region different in size or not? So we know that the square's sides are going to be 10 units. Now we need to know what the radius of the smaller circle is, which is r. So the smaller circle is where we're going to start, and we want to find the area of the smaller circle. So you're going to use pi r squared. So pi times the radius squared. Now, with the radius, or the smaller circle, the radius is going to be 1/2 of the square, so it's going to be 5. So here you have pi r squared, so pi times 5 squared. So then the area of the smaller circle is going to be 25 pi units squared because it's units that we just want to keep it that. We don't know if it's centimeters, meters, or anything like that. So once we find the smaller circle, we want to work with the larger circle. So the larger circle is going to be, we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. And our radius of 5 that we used up in the smaller circle is going to be what we use for A and B. So you will have 5 squared plus 5 squared equals r squared, which gives us 50 equals r squared. So now we need to find the area. And the area, again, is going to be pi r squared. And since we know that r squared equals 50, we know that the area is going to be 50 pi units squared. So we found the area of both the smaller and the larger circles. So now what do we do? Now what we're going to do is we're going to subtract the smaller circle from the larger circle. So you'll have A equals 50 pi minus 25 pi, which gives us a difference of 25 pi units squared. So knowing all of this, we know that the area of the region between the circles is the same as the area of the smaller circle, which is 25 pi units squared. Here we have a 3D shape. You have a cylinder, a sphere, and a cone. First, you want to find the volume of the cone. You're going to use the volume equals 1/3 of the base times height. But wait, we don't know the base. So we would have to do base equals pi r squared. And once we figure that out, then we could use the equation volume equals 2/3 pi r cubed. So we've got the volume of the cone. Now we're going to get the volume of the sphere, which is volume equals 4/3 pi r cubed. Once we have that information, then we can work on the volume of the cylinder. Again, just like the cone, you have an original volume equals base times height, but since we don't know the base, we would have to again use base equals pi r squared. And then our final equation that we would use for volume would be equals 2 pi r cubed. Once we have all three of these volumes, what we're going to do is you're going to divide the volume of the cone by the volume of the cone, which equals 1. The volume of the cone by the sphere is 2, and the cylinder by the cone is 3. So our ratio is 1 to 2 to 3. What kind of shape is this? Here we have a trapezoidal prism. On the next slide, I'll have another kind of example of another trapezoidal prism. So here we have the sides with 12 centimeters, 26 centimeters, 15 centimeters, 17 centimeters, and a height of 4 centimeters. So I want to find the surface area. And how do we do that? Well, the first equation, we're going to do the base. So the base is going to be half of A plus B times H, which is your height. And here, with this trapezoidal prism, A is going to be 26 centimeters, B is going to be 17 centimeters, and your height is going to be 12 centimeters. So you have half of 26 centimeters plus 17 centimeters multiplied by 12 centimeters. So your answer is going to be 258 centimeters squared. Again, don't forget to square your measurements because you're multiplying them together. So now we want the perimeter. Again, your perimeter is just adding your sides together. Don't add this 4 centimeters because that's the height, not a side. So you'll have 26 centimeters plus 12 centimeters plus 17 centimeters plus 15 centimeters. So your perimeter of this trapezoid is going to be 70 centimeters. Okay, now that we have this information, how do we find the surface area? So the surface area is going to be 2 times the base plus your perimeter and times your height. So right here we have the base of 258 centimeters squared, and we have the perimeter of 70 centimeters. And again, like I said, your height over here is 4 centimeters. So you have 2 times 258 centimeters squared plus 70 centimeters times 4 centimeters squared. So the surface area of this trapezoidal prism is going to be 796 centimeters squared. On this next slide, you're going to see another trapezoidal prism. So you're going to do it the same way. On the base, which is a half of the base times height, then you're going to find the perimeter, which is all your sides added together, and then you're going to add them together. So 2 times the base plus perimeter times height. And with this prism, your surface area is going to be 355 meters squared. Cylinders. So here we have a cylinder that's width is 8 feet and its length is 21 feet. So we want to find the surface area. So we know the surface area of a sphere is S equals 4 pi r squared. And the lateral area of the cylinder is S equals 2 pi r h. In order to find the total surface area, you're going to add both of these together. So you have 2 pi with the radius is going to be half of 8, so you have 4. So 2 pi times 4 feet times the height, which is 21 feet, plus 4 pi, again, your radius is 4 feet squared. You have a surface area of approximately 729 feet squared. Now, we don't only want to know the surface area in this, we also want to know the volume. So how do you figure the volume out? Well, the volume is going to be 4/3 pi r cubed plus pi r squared times the height. So we're just going to put these figures, or these numbers, back into the equation to figure it out. So you're going to have 4/3 pi times 4, which is your radius, again, feet, cubed, plus pi 4, again, your radius, squared, times your height of 21. Your answer is going to be approximately 1,324 feet cubed, not squared. All right, and this next one, it's the same kind of thing. You're working with the surface area of the cylinder, and the total surface area is going to be pi r squared plus pi r s plus 2 pi r h. So your s is your slant right here, and your height is how tall it is. So you have 2 being your radius, and you have 6 as your slant, and 10 meters is your height. So the total surface area is going to be approximately 176 meters squared. And then you'll also try to find your volume. Well, you have your volume equals pi r squared h1, your height, your first height, which is this 10 meters. Then you have another height up here, but you don't know what it is, so we got to figure that one out first. So your height 2 is going to be the square root of your slant squared times your radius squared. So 6 squared minus 2 squared. So your height, your second height, is going to be approximately 5.66 meters. So how do we figure out what the volume is altogether? You're going to do pi times 2 meters squared times 10 meters plus 1/3 of pi times 2 meters squared times your second height, which is 5.66 meters. So your volume is approximately 149 meters cubed. I really hope that I helped you understand a little bit more about volume, length, area, surface area, and all of that. But thank you, and have a good day.